So this is our second video of chapter vectors, class second. We had already done with 10.1. Now we are knowing that what are vectors. Now we'll see about the basic addition and subtraction of vectors. Let's see this. You can see this figure 10.7 on the screen. This is your AB vector and this is BC vector. We have to find AB plus BC. Suppose a girl is moving from A to B and then from B to C, means we have to find the final displacement by that girl. So this is the final displacement AC. So what we write here, AC is equal to AB vector plus BC vector. So this is the law of vector addition. Since it makes a triangle, so it is known as the triangle law of vector addition. We'll be doing the questions and then you will be able to understand more easily. So let's use that triangle law of vector addition in few more diagrams. Suppose we are given this A vector and B vector. In figure first you can see. This is A vector and this is the B vector. We have to add them. But the B vector is on the other side moving in some other direction. And this is the A vector. But we had already told you in the previous class, we are always going to use the free vectors, which we can move it without changing its direction and magnitude. So if I move this B vector to the final position of vector A, we'll be getting the figure like this second figure you can see. So now we can easily add this A vector and B vector, which is giving us this AC vector, that is A vector plus B vector. So this is the addition of two vectors. Now let's see for figure 3. Now if we add this vector, this B vector towards the downward side, it becomes minus B vector. And now this AC vector becomes A minus B, which is known as the difference of the given two vectors, that is A vector minus B vector. This is known as the difference of A and B. Now we'll move to the next law, which is known as a parallelogram law of vector addition. See here, now what we have to do, it is being shown here. Consider a boat in a river going from one bank to the river to the other in the direction perpendicular to the flow of the river. Then it is acted upon by two velocities. One is the velocity imparted to the boat by its engine, and the other one is the velocity of the river flow. Under the simultaneous influence of these two velocities, the boat in actual starts traveling with a different velocity. Because if they are in the same direction, they will be added. If they are in opposite direction, they will be subtracted. To have a precise idea about the effective speed and direction of the boat, we have the following law of vector addition. Now they are representing this A vector and this is the B vector. And this is the boat going where A vector and B vector, both vectors are supporting these two vectors. So how they will be showing it? Either you can take this A vector and join it to the final position of B vector. Then also what we are getting the final displacement? OC, which is A vector plus B vector. Or the other way around, you can take this B vector and join it to the final position of A, which will make us AC. So A vector plus B vector, we are getting here A plus B vector. So since it is making a parallelogram finally, so this is known as the parallelogram law of vector addition. But in this law also, we have already used triangle law of vector addition, right? Now let's see few properties of vector addition. This is your commutative property, like you are already studying from so many classes. From class 6th, I think you people are studying commutative property, but that was the case first with the numbers, then with the variables, and now it is with the vectors. That A vector plus B vector will be equal to B vector plus A vector. Let's see here. This is your AB is A vector and this is BC, which is B vector. And their addition is this AC vector, which is A plus B. Now let's see for B plus A. This is B vector and this is A vector. If we add this B plus A, again we are getting this AC only, which is B plus A vector. means ultimately this b vector plus a vector is equal to a vector plus b vector. So hence the commutative property goes for addition of vectors. Now let us see more for the associative property. This associative property also goes for a vector plus b vector in a bracket plus c vector is equal to a vector plus in a bracket b vector plus c vector. The diagram is here, you can easily see it. So this is also the property which is being used in the vectors. Now let's see multiplication of this vector by any scalar component. If a vector A is multiplied by any lambda scalar component, then the product A vector by the scalar is denoted by lambda into A vector. This lambda can be any number, any positive number. Like you can see here, it is A vector, this is half of this A vector, this is twice of this A vector, this is minus 1 by 2 of A vector, this is minus 2 of A vector. Like, right? Value of lambda is positive or negative, it also depends upon the given vector. If it is negative going on, means the direction is changed. So this is the visual representation. You can see here the direction means the angle, you can see it is just the same. If it is twice, we are making the magnitude double of it. So here when lambda is equal to minus 1, then lambda A is equal to minus A vector, which is a vector having magnitude equal to the magnitude of A vector, but the direction is opposite to that of A. The vector minus A is called the negative of vector A, and we always have a positive vector. If we add it to the negative vector, we'll be getting a zero vector. From here you can say finally we are reaching at the conclusion of a new formula which is known as the formula of unit vector. A unit vector is equal to A vector upon magnitude of A vector. So this is the formula for finding out the unit vector in the direction of A vector. Now here another diagram is there. This is a point P represented by XYZ since it is in space. It is a 3D point which is in space. And this O is the original point, the origin. If I want to write OP vector, then what I'll be writing it? Xi plus Yj plus Zk. Suppose a point is given 2, 3, 4. We'll be writing out this OP point as 2i plus 3j plus 4k. This form of any vector is called its component form. This is known as the component form. Sometimes the questions come, write the component form of the given vector. Here x, y and z are called the scalar component. This is x, this is y, this is z are known the scalar components of R. And xi, yj and zk are called the vector components of R along their respective axes, that is the x-axis, y-axis and z-axis. Sometimes XYZ are also termed as rectangular components. Since it is telling us about the length, breadth and height of a rectangle, so that is why they are also known as rectangular components. Now few properties are there, we should know about this. If this is the component form of a given vector, so its modulus will be under root of x square plus y square plus z square. Now, if two vectors are given by a1i plus a2j plus a3k and b1i plus b2j plus b3k, we can add those vectors. We'll only be adding what? Like we were adding for x and x, y and y, z and z. Similarly, here we'll be adding I with I, j with j and k with k. So what we are getting here? Same for the subtraction also. A1 plus B1, here A1 minus B1. A2 plus B2, A2 minus B2, and A3 plus B3, A3 minus B3. I, J, and K remains the same. Now, what will the option will be there? For the vectors to be equal. How they'll be equal? When A1 should be equal to this B1. Means the I component should be equal to the I component. J component means A2 should be equal to B2 and A3 should be equal to B3. The multiplication of vector A by any scalar lambda is given by lambda A vector. Means lambda A1i plus lambda A2j plus lambda A3k. Means that scalar number lambda will be multiplied by the full vector. Here we are just going through the theory portion before the exercise 10.2. Now here what they are saying. The addition of two vectors and the multiplication of a vector by a scalar together give the following distributive law. If I am multiplying a vector by any scalar k and again a vector with scalar m, we can also write like this. K plus m a vector. Or in case of multiplication, we can write like this. K ma into km into a. And for the third part, if I multiply a constant with the sum of two vectors, then also it will give us Ka plus Kb. If a vector A is given by A1i plus A2j plus A3k, here this A1, A2 and A3 are known as the direction ratios of A vector. Right? This we should know about it. And moving to the vector joining 2 points. If 2 points are given and their coordinates are given, and we have to write it in the vector form, just see how we are going to write. Suppose a P1 point is there with the coordinates x1, y1, z1, and P2 is x2, y2, z2. And we have to write P1, P2, means P1 to P2. So we'll be writing here as x2 minus x1 I plus y2 minus y1j plus z2 minus z1k. And its magnitude k will be given like this, under root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Whenever 2 points are given, then how to write it? This is the formation, how to write it. From P1 to P2, it is the given vector. And moving to the section formula. See here the section formula. Already we have done a kind of section formula in class 11th also, in class 10th also. Now here two vectors are there, A vector and B vector, and this R vector is dividing this OQP vector in the ratio M ratio N. And we have to find the value of this R vector. So see how we are going to find it out. See this, m into b vector plus n into a vector upon m plus n. Just the same way as we were writing in class 10th, since it is internally we use it in the form of addition. So in case of internally, it will be with the positive sign, means m into b vector plus n into a vector upon m plus n. And now for the externally, like the same way it is, just only a sign will be changed with a minus sign, m b vector minus n a vector upon m minus n. If suppose m and n are equal, means this is the midpoint. If it is midpoint, what it will become? This will become a vector plus b vector upon 2. In the next class, we'll be doing with exercise 10.2. So for now, it's over. And we'll be resuming it in the next class with the exercise 10.2. Few questions we'll be doing. And then we'll move further.